Hi everyone. I want to start by saying thank you all for coming. My name is Katsovich and I'm a product manager and software engineer. I've been in development for the most of my life and I'm passionate about building and creating products. In the little time I have today, I want to share with you a few of the things that made me a better developer, which I actually learned from my role as a product manager. I started to develop when I was 10, writing my first lines of code in HTML. I obviously loved it since I decided to learn computer science during high school and then kept developing for more than 10 years. Over the years, I worked with almost any kind of coding language that you can think of, and I had the privilege to touch all aspects of the engineering stack: front end, back end, Android, iOS, and even a little bit of DevOps. So essentially, most of my career and most of my life really, I've been working with code. A little over a year ago, I started working as a product manager at CyberReason, a cybersecurity company that I'm sure that many of you know. As I see it, engineers have a huge part in the success of the product. They are the inventors, designers, and creators. They get a set of requirements and restrictions like cost, security, and skill, and need to build the best solution that should fit another set of existing limitations like performance and backward compatibility. As a software engineer, every time I got a new task, I find myself immediately starting to think about the solution, jumping straight to what should be the architecture. Where is the problem in that bug? And when can I start to implement? I wanted to finish all my tasks as soon as I could, and I was running to how the feature should work on the system level rather than the product level. I always thought about creating the best code and best feature. But the truth is that writing great code doesn't always mean creating a great product. Working as a product manager kind of changed the way I look at engineering. As a product manager, naturally, I need to look at products from a different point of view. You see, in reality, our users don't care about the code. What they want is to have a solution to their problem. So I must focus on the value provided to them. This made me realize that what I used to think is the best way to go as a software engineer isn't necessarily true now when I understand the full picture. Today, I would like to share some of these insights and thoughts. Basically, I found that the typical set of questions often used by product managers are super relevant for engineers to ask themselves before starting to design and develop. These questions work with any feature, bug, or functionality. And I find that asking them not only helps me develop better products, it also makes me a better engineer. So, ready? The first question I always start with is, who is it for and what is the need? First of all, we should identify our users. Knowing who our users are and understanding what they need is important so we can make better engineering decisions. Here's an example. Let's think of a candy store owner, and to make it easier, let's call him James. James has a candy machine in his store, and he wants to know how many purchases are made every week. So as engineers, typically we would develop a report of all weekly purchases for James. Let's say James gave us the database of his store, and now we can write an incredible piece of code that would generate the weekly report. But before we jump right to it, we should take a moment to really understand James. Who is he? Why does he really need such a report? Well, he's a candy store owner and he wants to make sure he always has all type of candies in his store so we can provide all his customers' desires. This report should help him know what's in stock and what's need to be ordered. If we think of it now, a purchase report probably won't really solve James's problem. He will most likely will ask for another report for the missing candies so he can order more of them. This means that when designing, we probably need to build an infrastructure for multiple reports instead of creating just one. And if he needs to get a report once a day by email, it's really okay if it takes 10 minutes to generate it, because he doesn't stand and wait for it, right? But if we need to generate a report for his candy supplier at the moment that he enters the store, he probably wants to get it in 2 seconds. It's again a question of his need. In other words, thinking about the user and understanding what they want enables us to make better architecture decisions. Moving on to the next question. What does success look like? Or, in other words, what is the goal? Success means different things to different people. As a developer, I used to think of success as a code with zero bugs that is easy to maintain and sometimes even as the number of lines of code I've deleted. I'm not saying it's not important, but it's not the only thing that matters. Because in reality, this perfect code I wrote might have zero value to the user and product. Thinking about what success looks like for the business and how it can make an impact could make a difference. Success could be the company goal, like user acquisition or generating more sales, and it could be the goal for a specific feature or use case, like the expected user experience, the crucial of performance, or the importance of running in real time. Each answer generates a different design, and this can affect the solution as a whole. Let's see an example. Here's James again. Let's try to think about his goal. As a store owner, he probably measured the number of customers and purchases every month. So what does success look like? A lot of people that walk in and buy a lot of candies. And to understand how it will help us to make decisions, let's assume James has a new candy machine in his store that generates new candies every time a customer presses a button. Now let's say we try to improve the candy creation mechanism of the machine. We change the algorithm and it now generates 4 candies instead of 3 every time. But we also increase the time it takes to get the candies by 300 milliseconds. Should we keep this change or revert it? So it's an easy one if we are considering the big picture and James' overall goal. Let's ask, after this change, are we generating more sales? Do we have more people that buy more candies? If the answer is yes, we made a good impact and we improved our business performance. Keeping the goal in mind while developing immediately move the conversation to what matters the most and enables the right decision for the product. Moving on to the next question. What is the minimum value I can deliver? I'm sure you all heard about the product concept of MVP, minimum viable product. And as you already understand, I think it's relevant for engineers as well. The idea of the MVP is to introduce to our user the smallest piece of functionality as quickly as possible to get feedback and learn if it's valuable, and if not, change accordingly. As engineers, we should also care about developing in small chunks, so we could focus on one thing at a time and also to test our assumptions that we made while designing, like it will work at scale. And also our business hypothesis, so we won't waste time on something that won't fit the user, like improving a query to load a page that is barely used. For this example, let's say James wants to create a new candy machine. While designing, we should think of the best way a user can get a candy using the new machine, the most effective, straightforward, and intuitive way. And then, to back to our assumptions and ask, is it technically doable? What do we need in order to make it work? Do we have the time, the resources? And if not, what would be the smallest piece of code and functionality that will give value and that will help us to learn what do we need next? We want our code to be flexible, manageable, and easy to develop and maintain, but also relevant and valuable. And don't forget, time to deliver is also a parameter. A good delivery or feature is measured by value divided by time. If developing the best feature ever will take 3 months, it might not help some businesses because one of their competitors can easily develop something smaller and steal all their customer base. So it's always a matter of both time and value. Understanding that will help estimate how complex or difficult something will be and decide whatever feature will be worth the development effort. Delivering in small pieces creates a great environment to learn about what is needed, product and engineering wise. Last but not least, what else? This question is my favorite one. I personally use it all the time and I find it helpful not only at work. I really think it's the most important question one can ask. This is the time to think outside the box and ask, what else? What else I should know? Or what else can I do to improve? It's an opportunity for the product manager to mention anything that's important to them. And as engineers, we might benefit by getting more context of what we're doing or hearing about a quick win we can implement easily. What else I should think of? Maybe we already coded something similar once and some of the functionality exists. What else? Did we cover all use cases? What happens if we have more? Can we add them easily? Many edge cases are technical and won't be endorsed by the product manager. It could be broken APIs or insufficient memory. This is totally the time to collect all the missing information. And what else? Just ask. If you know how to answer all these questions that we've covered, I bet that you'll have more follow-up questions as well. So ask. Don't be shy. And the product managers might not mention something because for them it might be obvious, or they might not have all the answers. And maybe you'll have to think together and investigate. But if you ask the right question, you also might discover a better simple solution, something that wouldn't have come up otherwise. To conclude, programming for me is more than just typing code. It's the art of solving complex problems, building something from scratch, and think about all aspects. Asking this question is a proven way to get a clearer, broader picture of the problem and solution you're working on. And so it would be easier to come up with everything you need to build the best solution and become a better engineer overall. Thank you.